In the last video, I explained about how the support vector machines work without entering too much into the mathematics of SVM in detail. So, if you remember, I said a few things about the support vector machines. No, you have variable 1, you have variable 2, and then we try to draw the best direction where the distance between P max and P minimum will be maximum. So we have to find the right direction. So if you think the P max and P minimum is the distance between P max and P minimum is maximum, then we can say this vector is pointing towards the right direction in the support vector machine. So that's a, and then I also said something about the dimensionality reduction. You start from a two-dimensional data, plot the vector, and then you project the data. That makes your two-dimensional problem where you need two axes to show the to show that you have two different categories. And then once you project, you convert the two-dimensional problem into one-dimensional problem is in detail. So that's the first step that we have to do. And why we are doing all these gimmicks? So all this is to find the best direction where the separation is maximum, and then we identify the midpoint, and from there you draw your hyperplane. So hyperplane is the key line. So it's the main line. So you cannot draw anywhere this line. So we have to find the right place, or you should know where to draw this hyperplane in a two-dimensional axis. So that's what I explained in the previous video. And then these 2 points, P max and P minimum, these are nothing but called as a support vectors. So these points, one point is one vector, another point is another vector. So why do I call these 2 points as a support vectors? So I will explain. That's what we are going to learn in this video. So in this video, we are not going to enter into the mathematics, but we will see more jargons involved in the support vector machine. So or we can say the essential jargon. So that's what we are going to learn. So it's so in this video you're not going to see any mathematics, just the essential level of details that you should know in order to understand the so-called support vector machine. So let's begin with explaining something called as a vectors. So how do you define a vectors? So vectors in the language of SVM is their points, nothing but a point with meaning. Point with meaning. What does that mean? So you can measure the height and weight of the students. Let's call X, and then let's say we measure the height and the weight of the students, isn't it? So we can plot height on one side and you can plot weight on another side, and let's say you have some points like that. So maybe this group of points may belong to some students who are at some particular age, and this group of points may belong to some other group of students with a different age. So that's what this graph explains to us at the moment. So what's meant by vectors? So this is you have one pointing towards this side, weight, and then height we plotted on the y-axis, and each point tells something about height of the student and also the weight of the student. So you need two data, so variable 1 and variable 2 to explain the characteristic property of one student. So each point become a vector. So each point is a vector. So this vector has a meaning. So this vector tells something about height and the weight of the student. So that's why I call it as a point. So each point is something we can call it as vector, and each point has some meaning. It tells something about the quantities involved or the quantities that we are trying to measure. So it don't have to be two-dimensional problem. It can be even multi-dimensional. Yes. For example, let's say we measure the different properties of molecular weight, say maybe solubility, and few more things. Maybe ability to form a hydrogen bond, and so on. So let's say we have few more variables. So let's say we measured 5 variables to explain a particular molecule. So in this case you have 5 dimensions, so which means each point. So let's say molecule 1, and let's say we know the variable 1, 2, 3, 4, 5. So whatever the value that we know about that molecule, so all these points, so all these values tell something about that molecule, isn't it? So each dimension, so this is one future, another dimension is second future, third future, fourth future, and fifth future. So this is something called as the five-dimensional vector. So all of this contributes towards tells something about molecule. In this case, both height and weight tells something about the student, isn't it? So which means this is a two-dimensional vector, and each point in a two-dimensional vector. So each point in the two-dimensional space, you can call it as a vector, and in this case, each point in a five-dimensional space, you can call it as a vector. And then remember that. So whenever I say something called as a dimension, pay attention to this very carefully. So whenever I call it as a dimension, so dimension is not something telling about the space. So dimension is telling something about the number of quantities that we measured. So it tells about how many properties we actually measured. So if you measure height and weight, so that tells about the dimension. Doesn't tell about the vector space for the moment. So vector space will something we will define soon. So vector is something, is a point. It can be a point in a two-dimensional space. It can be a point in a five-dimensional space. It can be a point in an n-dimensional space. So vectors are nothing but a point that has some meaning. So that's something you have to remember. So I explained what is a vector. I also said something dimension. So dimension is something related to the number of things that we measured, or maybe number of futures that we measured. And then we can call something like a finite dimensional vector space. Still, I'm not using any mathematics. I'm not using any equations. Just something to know about the support vector machine. So you should know the basics, isn't it? You should know what is the vector first of all. So if you go back to this problem, so this point, each point is a vector, and so this particular point that dictates the margin is something called, each point is a vector. So this point is a vector, this point is a vector. Every point in this two-dimensional axis is a vector. So vector is just a point with some meaning. So finite dimensional vector space, which means what? So each data point is described by a finite number of futures. So if you have five futures, then we are in a five-dimensional vector space. If you have six futures, you are in a six-dimensional vector space. If you have n futures, then we have n-dimensional vector space. So if you have two futures like height and weight, 2D space, three futures, 3D space, 100 futures, 100-dimensional space. So what is this point? So for if it's a two-dimension, it's easy to draw in a graph paper, isn't it? How do you imagine the 5 dimensions? So five dimension is something like a particular row in a spreadsheet. So you have column 1, column 2, column 3, column 4, column 5, and this particular row tells something about molecule 1. So this whole row, something that you can call it as a point in a 5-dimensional space. Okay, so I think this is something good to learn. And now in the previous video, I tell something called as a hyperplane, the line that separates these two groups in a two-dimensional vector space, isn't it? So let's see something how the hyperplanes looks like in different space. Yeah, so let's say if we have a two-dimensional data, let's say we have some points here. So if you want to separate these two categories, you draw a hyperplane, isn't it? Yeah? So which mean in this case, if you have two-dimensional space, 2D space, then the hyperplane is a line. So this line is one-dimensional, isn't it? Yeah? So if you have a 2D, two dimensions, let's say dimension of the data. If the dimension of the data is two-dimensional, then the separator or the hyperplane is one-dimensional. Yeah? And let's say if you have the dimension of the data, let's say we've just measured the height of the students. Yeah? So these students belongs to age 5, and then another height of the students, their age may belongs to 14 to 16. Yeah? So clearly you have some data points, isn't it? Yeah? So this is just a one-dimensional data. All we are trying to plot is everything in one dimension, and you can see some clear separation between these two. And if you want to draw a hyperplane, that hyperplane will be, you take the maximum in category 1 and the minimum in the category 2, and then exactly the midpoint of these 2 points, that becomes the hyperplane. So this point, so this particular point separate category 1 from category 2. So if a point lies to the left side of this point, say like somewhere here, so in that particular person will belong to category 1. If you have some point to the right of this midpoint, then they may belong to category 2. So what do I mean by that? So if you have one-dimensional data, your hyperplane will be just a point. That point is a zero-dimensional. Okay. So if you start with a two-dimensional data, hyperplane will be one-dimensional. If you start with the one-dimensional data, hyperplane will be zero-dimensional. The rule is same. You know? So you will see, let's say you have a three-dimension. You should have some patience to learn this type of machine learning algorithms. At the moment, I'm not even introducing any mathematics, just explaining the fundamentals or the essentials that you should know in order to understand support vector machines, or even to solve a problem using support vector machine. That's something we will see at later stage. So if you have some points here, so this is a three-dimensional space. Yeah. So how do you separate this one? Yeah. In this case, you may need to find the best plane that separates. It's like a plate. You're just assuming that you have a plate. You're going to separate rectangular plate. So to separate category 1 from category 2. So what do I mean by this? So if you have a three-dimensional space, so if the dimension of data is three-dimensional or 3D space, then your hyperplane, it's a plane, isn't it? Yeah, which means you have some direction here, another direction here. So it will become a 2D. Your hyperplane will be two-dimensional. So if a dimension of data is 2D, hyperplane will be 1D. Dimension of data is 1D, hyperplane will be 0D. If a dimension of data is 3D, your hyperplane will be 2D, which means if your dimension of data is ND, n dimensional, then the hyperplane will be n minus 1 dimension. Yeah? So keep these things in the mind. So at the moment we are trying to learn some essentials that you should know about the support vector machines. For me, it's easy to solve a problem with a two-dimensional data, but if you have higher dimensional data, your hyperplane dimension will be something like here. Yeah? So your hyperplane will be one-dimensional if you have two-dimensional data. Your hyperplane will be zero-dimensional if you have a one-dimensional data. So that's how it works. And then now we are going to introduce something called as, how do we call this? Let's call this as a vector space. The notation for vector space. So the common notation is r power n. So what do I mean by that? So if it's r power n means we are dealing with n-dimensional space. r power 2, that means we are dealing with two-dimensional space, which means we have data in that something like each point is represented by two variables, or something like two variable 1 and then variable 2. If it's R3, that means three-dimensional space. If it's Rn minus 1, that means n minus 1 dimensional space. So these are some common notations. So we are not entering into mathematics. I'm just introducing the jargons in the support vector machines. So what if R, for example, R3, what does this means? Which means all points, so it's a vector space, isn't it? Yeah? So in R power 3, in this space, each point is represented by three real numbers. Yeah? It can be height, weight, or maybe, I don't know, I don't know how to, maybe the mark of student in some particular subject. Yeah? So if it's R power 4, each point in that space is represented by 4 different variables. So that's the meaning of that. Yeah? I think this should be enough for the moment. The next video I will give you some data, and then once the plot that may look exactly like this, and then we will try to find the ideal vector or the right direction, and then we will try to project the points onto that direction, and then we will try to find the support vectors, which will be P max and P minimum, and then we will try to find the minimum point, the midpoint between the support vectors that measures the distance between the support vectors, and then we take the midpoint, and then we will draw the hyperplane. Yeah? So we will do this in a so we will try to solve this problem, or in other words, I will introduce the mathematics in the next video. So this should be enough for this moment. So in the next video, I will solve some real problem using the support vector machine. So